Hi everyone and welcome back. Today we're going to be talking about chemical reactions, including single, double replacement, synthesis reaction, decomposition reaction, and combustion reaction. These all fall under the chemistry topic, and we're just going to be going over what each of these reactions mean and some examples of them. So first we're going to start off with single replacement and double replacement. So single replacement is specifically a type of chemical reaction where one element is replacing another element within a compound, and it results in a new compound and a different pure element. And the reason why this tends to happen is because the replacing element, or the element that's replacing the other one, is more reactive than the one being replaced. Okay, now let's talk about double replacement. So a double replacement reaction is when two ionic compounds in a solution exchange their positive ions or cations or negative ions, also known as anions, to form two new different ionic compounds. Okay, so now I want to explain the general formula for these. So specifically in single replacement reaction, we would have A plus BC in the reactant side and then AC plus B in the product side. So what this is showing is that A, in this case, is replacing the B, which is why now the B is by itself, and now A is with C rather than B being with C. So basically, in this case, A would be more reactive than B, which is why it's replacing it. So once again here, the replacing element, being A, is more reactive than the one being replaced. So A, in this case, is more reactive than B. And another thing I want to add is that single replacement reactions, they form the basis of copper plating and steel production. For the double replacement reaction, the general equation would be AB plus CD in the reactant side and then AD plus CB in the product side. So in this case, AB and CD, these are ionic compounds, right? And these are also ionic compounds. However, they're replacing each other, so they're exchanging cations and anions. So rather than A being paired up with B, A is paired up with D. And rather than C being paired up with D, C is paired up with B. So what happened is that they switched partners, you can say. So they formed two new and different ionic compounds, because obviously AD is no longer the same thing as AB as you had on the reactant side. And I want to add that on top of forming two new and different ionic compounds, it also results in a precipitate, gas, or water. And also, these double replacement reactions, they're fundamental to water softening, antacids production, I think that's how you say, and soap scum formation. So these different reactions, they're visible in the real world, and we can see how these reactions shape physical things. Okay, now let's talk about synthesis reaction. So in a synthesis reaction, you're basically combining two or more simple reactants, which in this case is A and B, because they're in our reactant side, and they come together to form a single and more complex product, which would be AB. And just to give you guys an example, let's say we have 3 moles of hydrogen, right? And we combine it with 1 mole of nitrogen. They're going to come together to form ammonia. So here, our 2 simple reactants is hydrogen and nitrogen, and they're combining to form a single, more complex product. Okay, so now let's talk about decomposition reaction. So decomposition reaction is almost like the opposite of synthesis reaction, because here we're taking the single complex compound, right, and we're breaking it down into 2 or more simpler substances. So once again, in the general formula, you have the complex compound, which is AB, and it's breaking down into these 2 simpler substances. So it's like, the word decomposing, it's like breaking down. So as I said, it's the reverse of a synthesis reaction. Okay, and last but not least, you have combustion reaction, where it's basically a substance reacts with oxygen gas and it releases energy in the form of light and heat. And typically the reactant is a hydrocarbon, and it's basically just a compound that's made up of solely carbon and hydrogen. And it's reacting with the oxygen gas, and most of the times, if not all the times, the products of a combustion reaction contains carbon dioxide and water. And I also want to add that many hydrocarbons are used as fuel because their combustion releases very large amounts of heat energy. So, as I said, heat and light, that's what they're releasing. That's why they would be useful to use as fuel. A good example of this would be propane, which is a gaseous hydrocarbon that's commonly used as the fuel source in gas grills. So, just to summarize, in a combustion reaction, your reactant side typically contains the reaction between a hydrocarbon and oxygen gas, and then your products would contain carbon dioxide and water.